as I said in the last problem, so this is example number 3, and really on example number 3, we want to focus on that distance. And I want you guys to know something. If we have a graph in the xy plane, and I have a point here, and a point here, and a point here. Actually, if I have a point A here and a point B here, and then I take and I draw a line segment between them, I can actually take, if I go from here to here, and from here to here, well, that makes a right angle triangle. And so, well, how do I calculate the distance from this point to this point? Well, first let's label some things. This right here would be x sub 1, comma, y sub 1. And this point over here would be x sub 2, comma, y sub 2. Okay? Now my question to you guys is this. How do I figure out the distance from there to there, based on the information they give us? Well, the distance from here to here would be x sub 2 minus x sub 1. Right? Does that make sense? Do you trust that it does? You may be a little confused, but that's the distance, right? So I guess what I'm saying is that we're measuring from here to here, and when we talk about the x-axis, this x sub 2 value would be the same for this point as it would be for this point, wouldn't it? The x part. They have different y's, but the x part would be the same. And then this one has an x value all by itself. But when we want to find the distance, we almost always start with the last value and subtract the first value from it. Okay? Does that make sense? Now does it make more sense? Likewise, if I wanted to find the distance from here to here, well, that would be, let me write this over this way if I have room, y sub 2 minus y sub 1. Same principle. This is the y sub 1 value is just going to be y sub 1, and the distance from here to here, well, actually we're going from here to here, and then we're subtracting y sub 1 from it. But that's how we find the distance. Okay? Now think about this. When I'm done with all this, doesn't this make a right triangle? Well, if I take that right triangle and I do it like this, isn't that the same as A, B, C? And we know that their relationship of right triangle sides is A squared plus B squared equals C squared. All right, that's a Pythagorean theorem. So how would I write that in terms of x's and y's? Well, if I wanted to know the distance of this right here, what I'm really interested is in what? A, B, or C? C. I'm interested in C. But my formula has C squared. So what could I do? Yeah, let me give myself a little more room. I'm going to say C squared is equal to A squared plus B squared. And yeah, you're right. I could take the square root of both sides, and that would say C is equal to the square root of A squared plus B squared. And then the question I ask you guys is, well, C represents the distance, right? The distance from point A to point B, right? So I could say that the distance D, or the measure of AB, is equal to the square root, but they don't always tell me what little a, little b is, but I know that this is little a, and that this is little b. So I could say little a, which is really x sub 2 minus x sub 1, and I got to square that, right? Plus y sub 2 minus y sub 1, which is little b, and I have to square that. Does that make sense to you guys?
What is the AB? So distance equals A?
Yeah, that's just saying the distance from A to B, the measure of the distance from A to B. Okay? And I use the capital D. Your textbook uses a lowercase d. Okay? Any questions so far? We haven't even started yet. So now, your textbook, here comes example number 3. They've given us the point -7, 5. That's u. And that occurs at -7, 5, which is our first point. So we'll call that x sub 1, y sub 1. And then they give us the other point of v, which is at 1, 2, 3, 4, down 3. 1, 2, 3. So that's v, and that's positive 4, negative 3. And that's x sub 2, y sub 2. And your textbook asks us, very politely, if we could pretty please find the distance between those 2 points. How do I do that? Just plug it in? Alright, we'll try. So we'll say that the distance between these 2 points is going to be the square root of this squared plus this squared. What's x sub 2? 4. Minus x sub 1, which is? Notice that I have the minus sign.
So really you're adding 7.
Yeah, I like to write it like this. Minus, minus. And then you never make a mistake. Alright, cool. Now we need y sub 2, which is -3, minus 5. Now Mr. Adams likes to do a little shortcut work here. You're correct. When we minus a minus, it becomes a plus. So this is 11. And 3 minus 5 is -8. So my distance then will be the square root of, what's 11 squared? 121. Plus, what's -8 squared? 64. Right? What's 64? Is that 185? The square root of 185. Now that's the exact value. I suppose if you were to plug that into a calculator, we need the square root of 185. So if I hit second and I see that little square root symbol right above the x squared, and I hit 185. Now when it has that little right triangle that's saying, hey, if you want to get out of the square root thing, just hit your right cursor, boom, now you're out. I'm going to hit enter, bam. Now some of you guys may have an older calculator, and it may be in classic viewing mode, and you could go to the classic viewing mode by hitting mode, and then from the top, just go to classic, and then it looks a little different. So if you're ever on YouTube and you look up like some of these things, now it would look different if I were to go second square root. It has the parentheses thing. Now some of you guys may have an older calculator, and so you would do this. You gotta make sure you close the parentheses, but it's the same thing. And so my answer is 13.6. Does it tell us how far to round that to? Round to the nearest tenth. Well, what's the 10th spot?
6.6.
All right, so let's talk about how we round to the nearest tenth.
I don't know.
Yeah, well, be quiet. I'm going to tell you anyway. So it's going to be 13.601 something, right? Boom, boom, boom. And remember that this is 1 over 10. That's the tenths. This spot is the hundredths, and so on and so forth. So to round to the nearest 10, we look at this number. If it's 0 to 4, we round down. If it's 5 or larger, we round up. Since it's 0, we round down, which is approximately. The squiggly equal sign lets the reader know this was rounded. 13.6.